Hello, I am P. Shanmuga of Civil Department from Vel Tech, Rangarajan Dr. Shanmuga R&D Institute of Science and Technology, Avadi, Chennai. First of all, I would like to thank the Triple D department for providing us with this great opportunity to work at L&T Constructions. I would also like to thank our external guide, Dr. L.S. Kannan, and also our internal guide, Mrs. M. Annapurani, for providing this incredible support to complete our final year project on the topic the effect of fire on high performance concrete. This project was done by me along with my group mates Alok Singh Yadav and Aravinth Kumar. Now let us start with our slides. First of all, these are the basic objectives of our project. First of all comes to identify and do the preliminary tests on the materials that are to be used. Next is to study and prepare the mix design for high performance concrete of grades of M40, M60 and M80. At last we did for to study and compare the thermal properties of high performance concrete under different temperatures. The next comes the scope of our project. Usually the high performance concrete doesn't provide adequate fire resistance for most applications. So this study deals with the strength and durability properties of concrete which are significantly affected when subjected to elevated temperature. Now next comes the methodology. For our methodology, we did these 6 steps to complete our project. First of all, we collected the various literatures and then reviewed it. These literatures are from various published journals, while the next step was to collect the materials and to do various preliminary tests. Then we did the casting and curing of these high performance concretes and then we did the testing of concrete cubes after 3, 7 and 28 days of curing. At last we did the analysis of our performance, that is the compressive strength of the cubes. At the end we concluded with our conclusion. We concluded with a conclusion. As you can see, these are the various literature review. First of all is the durability of high performance concrete subjected to fire temperature impact by Jacques Reg W. As you can see here, he is explained that the use of high performance concrete in tunnel structures when subjected to high loads have the possibility of extreme load occurrence such as fire, which is increasing significance. So he aimed at improving high performance concrete properties in high temperature conditions. Similarly, for research, next review was on review on research on fire resistance of ultra high performance concrete by How Wen et al. He saw the fire resistance in ultra high performance concrete was measured under different temperature and loading, and at temperatures of 200 degrees Celsius, 300 degrees Celsius, and 400 degrees Celsius, at loading at 30% ultimate strength. Similarly, various literatures were reviewed. At last, this is the materials used. As you can see, we have used crushed sand instead of reverse sand, and we have used fly ash, micro silica. This is the silica materials of micron size, 1 micron size, while at the last we use cement of OPC 53 grade. As you can see, these are the our progress of work at L&T Constructions. First is the quartering of sample. Next we did our test on dry look bulk density. The next is cement consistency test. Then silt and clay content test, and at last CV analysis. As you can see, CV analysis was done on 20 mm coarse aggregate, 10 mm coarse aggregate, and fine aggregate, that is crushed sand here. First of all, for CV analysis of 20 mm coarse aggregate, as you can see, 97%, about 97% was the passing percentage for our materials used, which was within IS limitations of IS code 383/2016. Similarly, for 10 mm coarse aggregate, this was also within our limitations of IS code 383/2016 of within 77%. At last, for seam analysis of crushed sand, as you can see, the passing percentage of zone 2 sand was 56% for 600 micron, which was also within IS limitations 383/2016. Those materials which did not reach our limitations were rejected. Now we did our tests on 20 size aggregate and 12.5 size aggregate at last for crushed sand. The next test was dry loose bulk density. For dry loose bulk density, first of all, the empty weight of container was taken. Then the aggregate was filled inside the mold from a height not more than 50 centimeter, 50 sorry. Then the filled mold was weighed again. At the end, with this formula of aggregate weight by volume of cylinder, the density was found out. Similarly, it was done for 12.5 size aggregate and also for crushed sand. Next was the specific gravity test, which was done by using pycnometer. First, the materials was filled inside the pycnometer for a height of about 2 by third of its total height. Then water was filled inside it and was weighed again. By using the specific gravity formula, we found the specific gravity of the materials that we have used. And next comes water absorption test. For water absorption test, the materials were soaked in water for 24 hours, then kept in sunlight in room temperature until it reached the SSD condition, then was weighed. After weighing it, it was put into oven and again and was heated at 100 degrees Celsius for about 2 hours. Then we again weighed the sample, after which we got the water absorption percentage. Next comes the determination of percentage of silt and clay. In this, the material, the sample of 100 gram sample of river sand and crushed sand was taken in a 75 micron sieve. On after which it was held on running water. At the end of this running water was stopped until and unless we did not see clear water. So after we reached the clear water, the sample was weighed again and was seen how much is the change in the weight. At the end, we saw that for river sand it came about 3.57%. For crushed sand it came of around 14%. For allowable limit for crushed sand it was within 15%. Within 15%. So this material was used. Then we did impact test on coarse aggregate, for which the coarse aggregate was taken in a small mold and was heated use impact using the impact test apparatus, and the impact percentage came out about to be around 18.5%. Next we did the consistency of cement. For consistency of cement, as you can see here, we got to around 29 to 30%, while the consistency came around 8.5 for 29%, and for depth of penetration came around to 8.5 for 29%, while 5 for 30%. The allowable limit for consistency of cement is 5 to 7 so for 30% we got our allowable limit. Next we did the initial and final setting time of cement. The initial setting time of cement came around to be 140 minutes, while the final setting around of cement came around to be 20 minutes. At last we did the fineness by dry sieve method, where the weight retained came around 7 grams out of 100 grams. So that is 7% of initial weight. As per code, the allowable retained weight is 10% of initial weight. So this material was within limits. As you can see, this slide shows the materials used per meter cube. Therefore, as you can see, for M40 the microsilica has been not used, while for M60 the 15 gram was used for microsilica. For M80 it rise for around 50. Next, these are the progress of work for cube casting at LNT. The various cubes were casted, about 36 cubes were casted at a time. As you can see, the first picture shows the various cubes casted. Second picture shows the oiling of the molds for allowing the easy taking out of cubes from the mold. Third one is the mixing of the concrete, and the fourth one is the mixing of the concrete by using a mold. Next is mix design ratio. For M40, the mixed design ratio came around to be 1 is to 0.263 is to 1.881 is to 1.692 is to 1.129, and the water cement ratio came around to be 0.50. For M60, for cement is to fly ash is to microsilica is to crushed sand is to 20 is to 10 The 20 and 10 are blended here. while the ratio came around to be 1 is to 0.188 is to 0.033 is to 1.48 is to 1.449 is to 0.967, while the water cement ratio came around to be 0.40. While for M80, the ratio came around to be 1 is to 0.333 is to 0.111 is to 1.231 is to 1.433 is to 0.955, while the water cement ratio came around to be 0.39. Now, next slide shows the quantity of materials that has been used in kg. As you can see, in M40 we used about for 19 kg of cement. For M60 this rose to around to be 22.5. For M80 it was remained same at 22.5. The major difference in M60 and M80 came around in the microsilica content. The microsilica use was 0.75 in M60, while M80 it came around to be 2.5 kg. Apart from that, the core segregate crust chant came around to be 33.3 in M60, while for M80 it was less in content in 27.7. And the admixture of aurum mix 350 was also added in ml. For M40 it came around to 120, M60 193, for M80 it was 260. A total of 108 cubes were casted, 36 each in each grades of concrete. This is the workability of concrete. As you have seen, M40, M60 and M80. The water cement ratio came around to be 0.5, 0.4 and 0.39, while the slump cone value came around to be 100, 110 and 115 mm. While the basic workability should be within the range of 70 to 120 mm, this was within the allowable limits. Next is the various pictures showing our progress doing while slump cone test. As you can see here, this is the muffle furnace. First picture shows the cubes being put into the muffle furnace. The below photo shows the cubes being kept at 400 degrees Celsius. The center one shows the cube being taken out of from the muffle furnace and kept at room temperature after heating it at 800 degrees Celsius. The fourth photo at the right corner shows the compressive strength test. At last, the cube being cracked after compressive strength test. Next comes the various tabulations that we have observed for our observation. The first one is M40 grade of concrete, and the area of cube was 100 mm into 100 mm. The days of curing were for 3 days, 7 days and 28 days, and total of 3 trials were done for each days of curing. First the cube was weighed, then it was loaded in compressive strength and the compressive strength was noted. Similarly, it was done for M60 also with the same area of cube and same days of curing and 3 trials. At last we did for M80 also for area of cube of 100 mm into 100 mm and the days of curing of 3, 7 and 28 days with 3 trials, with a compressive strength max of 87 at 28 days and 67 for M60 at 28 days, while the 51.55 for M40 at 28 days. Now this tabulation shows us the concrete cubes being heated at 400 after heating at 400 degrees Celsius and then done for compressive strength. These cubes were heated for about 1 hour and the grade of concrete is M40. Similarly, for the tests were done after 3 days and 7 days and 28 days of curing. 3 trials were done again, and the cubes were heated. Cubes were weighed even before heating and also after heating to see the variation in weight. Then the cube was loaded in the machine and compressive strength was noted. As you can see here, the strength of concrete came around to be 48.77 after heating it at 400 degrees Celsius, while for M40 at normal room temperature it was around 51.55. There is a small rate of degradation in the compressive strength. Now next comes M40, which was heated at 600 degrees Celsius for about 1 hour. Similarly, the compressive strength was noted as the same procedure. Now the strength came around to be 37.93, which is about 70% of the strength that we had initially of our target strength. Well, the last we did for M40 at 800 degrees Celsius for 1 hour heating, and this show a major drawback that about it did not provide us more than 40% of our initial target strength at about 24.33 megapascal. 60 grade of concrete was heated at 400 degrees Celsius for a duration of 1 hour. Same procedure was used, and the compressive strength came around to be 47.6 at 3 days of curing, and 52.53 at 7 days of curing, and 58.37 after 28 days of curing, which is still at 90% of our target strength. For M60 grade of concrete at 600 degrees Celsius for a duration of heating of 1 hour, this came around to be 45.33 after 3 days of curing, 48.7 after 7 days, and 51.8 after 28 days, which was about 73% of the strength. For for M60 at 800 degrees Celsius, this strength again had a major drawback, as the strength came around to be 21 after 3 days of curing, 24.96 after 7 days of curing, and 29.97 after 28 days of curing. Now M80 grade of concrete was also done the same procedure, first heating at 400 degrees Celsius, and heating of duration of heating of about 1 hour. The strength came around to be 54.33 after 3 days of curing, 56.97 after 7 days of curing, and 62.07 after 28 days of curing. Now for M80 at 600 degrees Celsius, the strength came around to be 49.66 after 3 days of curing, 53.63 after 7 days of curing, 58.33 after 28 days of curing. At last, for M80 at 800 degrees Celsius with a 1 hour duration of heating, the strength came around to be 28.63 after 3 days of curing, 33.47 after 7 days of curing, 37.33 after 28 days of curing. The cubes being handled after taking them out from upper furnace. The second one shows the compressive strength test being done. Third one shows the cubes being inserted into the muffle furnace. Third one shows the compressive strength machine, digital compressive strength machine. Next two cubes shows the cubes after being placed in compressive strength machines. Now this graph shows the decrement of compressive strength after 3 days of curing. The strength for M80 is being denoted in yellow color. For M60 it is denoted in red color. For M40 it is denoted in blue color. As you can see, the strength of M80 decreased from 64 to 53 after being heated at 400 degrees Celsius, while for 600 it decreased to 49, and at 800 it decreased to 28. As you can see, there is no major decrement up to 600 degrees Celsius, but after 600 to 800 degrees Celsius, this has a major downwards curve, which shows that above 600 degrees Celsius the rate of degradation increases, and at which rate it is degraded, it has been discussed in the conclusion. Similarly, for decrement of compressive strength after 7 days also had a major drawback, like having the strength decreased after from 600 to 800, it had a downward curve. Then for decrement of compressive strength after 28 days, the M40 M60 had a small inclined curve only, but for M80 this had a major downward curve. This was because of the microsilica content being added in the concrete cubes, while for M60 and M40 the amount of content of microsilica in M40 was 0. For M60 it was very minute, so the water content was also increased, because of which the cracks were late to occur. Now for our result and conclusions. As you can see, the rate of degradation for M40 grade of concrete from 400 degrees Celsius room temperature to 400 degrees Celsius was around 5.39%. For 400 degrees Celsius to 600 degrees Celsius, it came around to be 13.04%. For 600 degrees Celsius to 800 degrees Celsius, it came around to be 29.20%. Similarly, for rate of degradation of compressive strength of M60 grade of concrete after from room temperature to 400 degrees Celsius came around to be 22.20. For 400 degrees Celsius to 600 degrees Celsius, it came around to be 11.20%. For 600 degrees Celsius to 800 degrees Celsius, it came around to be 6.02%. At last, for the rate of degradation of compressive strength of M80 grade of concrete for room temperature from room temperature to 400 degrees Celsius came around to be 35.80%. For 400 degrees Celsius to 600 degrees Celsius, it came around to be 42.14%. For 600 degrees Celsius to 800 degrees Celsius, it came around to be 36%. As you can see, for M80 grade of concrete, the rate of degradation for each of them has been on the highest side, like 30%, like 35%, 40%, and again 35%. Among these three grade of concrete, only M40 had the less range of rate of degradation, like 5%, 13%, and 29%. So from the above summary, the rate of degradation of M40 grade of concrete from room temperature to 400 degrees Celsius doesn't lose its target strength, while for the same grade of concrete, the compressive strength had a change in the range from 30 to 40. While for temperature of 600 degrees Celsius to 800 degrees Celsius, it doesn't even provide us a 50% of the mean target strength. So even the strength of concretes of M40, M60 and M80 also very similar way of M40, but among all the grades of M40 uh, is within the limit. Hence M40 is effective grade of concrete when compared to other grades of concrete. While for other grades of concrete, there is a major scope for us, like we can add various composite materials to increase its strength and also to reduce its easy cracking. At last, these are the various references which we have incurred from various journals and also from IS codes, and we thank them all. And that's all for the presentation.